Saxon Algebra 1, Lesson 31. Our topic, students, is equations with parentheses. I don't like to write out parentheses. It's a really long word, so I just make parentheses. And a lovely fact about parentheses is that they talk. They do. They speak to us, but they always say the same thing, and that's helpful. What they say is, do me first. And we remember that in our order of operations, they're at the top of the list, aren't we? We're going to get to that in a minute. But I want to give you another helpful fact about parentheses, is that they're part of a larger club called Symbols of Inclusion. And all the members of this club look kind of the same. There's your basic parentheses that are rounded-ish, but you can also have squared off parentheses, or you can have the fancy pointy kind. They have special names, but they're all symbols of inclusion, and they all speak the same language. They all say, do me first. So let's tackle a few problems. The problems will look fairly similar to what we've been doing, but they're now going to have symbols of inclusions in them. So that's cool. All right, example 31.1. And it tells us to solve. And then it gives us a cool equation. Before I write the equation, I want to remind you of something. Whenever our instructions tell us to solve, that means we have an equation. We have a mathematical expression with an equal sign, and our answer will be something like x equals 46. This is the kind of answer we will have if we're told to solve an equation. If we're told to simplify, that means there's no equal sign. And so we call that an expression. It's something complicated that can be reduced, but there is no equal sign. And our answer is not going to be quite as satisfying. The answer is going to be a cleaned up version, if you will, of what we're starting with, but it's not going to give us a nice crisp answer like that. This problem tells us to solve, so that's great news. That means we're going to get that nice crisp answer. I'm copying. All right, we're going to work a few of these problems, and then at least one of them, and then we'll develop a set of rules, a set of steps to follow. All right, so when we look at this, we see, yep, sure enough, there are parentheses, symbols of inclusion, and they speak to us. They say, do me first. But we look at them and we go, 3 minus b. There's nothing we can do. There's nothing we can do within those parentheses. And they don't just represent multiplication, right? They're more complicated than that. So what we remember is that sometimes do me first, whoops, I spelled first wrong. Do me first means distribution. Not always, but a lot of times in these problems that we're going to be doing, that do me first means we want to distribute. So that's the very first thing that we'll do. 2 times 3 is 6. 2 times minus b is minus 2b. And the other side is unchanged. We just copy it along. All right. Well, we can either swim the b's to the left or the right, and then swim the plain numbers to the other side. It's totally our choice. Just randomly, if you were here, I would let you choose, but you're not. So I'm going to choose to add 2b to both sides. Later, we'll talk a little bit more. Well, we've already talked about it to some extent. You can be strategic, right? You can see, oh, if I swim it this way, they'll end up being positive, and I like positive b's. That's fabulous. Let's do that. Okay, so I get a big fat cancel there. I get 6 equals 3b minus 5. So it looks like I'm going to have to swim my plain fish this way, right? They go in the opposite direction. I get 11 equals 3b, because that cancels. I divide both sides by 3, kaboom, and I get b equals 11/3. That might not be the answer of your dreams, but it is an answer where we solve for the missing letter, and it is correct. All right? So, symbols of inclusion. Let's see, we have a total of 5 examples in this lesson. I hope the light is okay. It was pouring all day long, and then literally the minute I got out my notebooks and started to set up to record, the sun came out, which makes my life much harder. I have a blanket protecting this so that the sun doesn't shine on my page too much, and it's creating little speckles. Okay, now Grace wants to go out because she knows it's not raining. Hang on, I'll be right back. What is it, princess? You want to go out? How'd you go? Good girl. Grace is recovering from trauma. She had a broken tooth, a cracked tooth, and it created an infection in her little face. So yesterday she had her teeth cleaned, and then they pulled that tooth and they actually found another one that was cracked. So she's recovering from the drama and trauma of a day at the vet. And she didn't have to spend the night or anything, but still, you know, she was there for, I don't know, 6 or 8 hours. And she can only eat soft food, but her appetite is ravenous. So it's called, What Can I Make My Dog to Eat? Peanut butter bread, how does that sound? She likes it. She likes everything. Okay, let's do another one, and then we'll make up a list of what exactly it is that we're doing. Number 2. There we go. The parentheses catch our attention because you know what they're saying. They're saying, do me first, please. I need you. They're you know that friend, everybody's got one, that just needs a little extra attention. That's what symbols of inclusion are. You know, they just have to get everybody's attention before they cannonball into the pool, or they have to wear the, you know, most outlandish outfits, or their voice is always just that much louder. That's what the parentheses are, the symbols of inclusion. They're that friend that just needs the attention. In this case, we have 2 sets of parentheses, so we'll do them at the same time. I'm drawing my little whoop-de-doops to remind us that, oh yeah, there's 2 multiplications for every set of parentheses that we're distributing. 3 times 1 is 3. 3 times 2x, is 6x. Now this 7 is just chilling out here. He's not part of the distribution, so we'll just add him. Now, this is very important. That minus sign has to get distributed along with the 4. It's not harder. We just have to be careful and distribute this as a bundle, if you will. Minus 4 times x is minus 4x. Minus 4 times positive 2 is minus 8. Okay, we're good. Now, before we go on, we're going to add these like terms. So we'll have 10 plus 6x equals minus 4x minus 8. Notice that it doesn't really matter on the sides here if we have our x's first or the plain number first. We're going to rearrange it all anyway, so it doesn't matter. Okay, again, I get to decide. I'm going to swim my x fish this way because I would like to have a positive number that I'm adding. And because we are advanced equation solvers at this point, we can do both swims at the same time. We brought the x's this way, so let's subtract the 10 and get the plain numbers over here. If you feel confident in yourself as an equation solver, go ahead and swim both sets of fish at the same time. If that blows your mind, it's fine. You don't have to. But it just saves you, it's just a little bit faster. 10x equals negative 18. Divide both sides by 10. And as we do this, we notice, oh, these are both even numbers. So I can reduce this, right? I can essentially divide it by 2 over 2. I can do that in my head. I don't have to write it out. I'm doing it just to show you. But we get x equals minus 9 over 5. Remember that when we have fractions with negatives, we tend to float. Mine's sitting a little bit too high, but I'm not putting it right by the 9. I'm floating it a little bit. Okay, let's make our list now of what it is that we're doing in these steps. The first thing that we're doing is distribute. And again, let me give you the visual on that. Just a second, Grace. She wants back in. I'll finish this and then I'll go get her. The second thing that we do, that we had to do in this one, was we add like terms, right? Sometimes when we distribute, we may have other terms and we can mush those together as need be. Then we swim our fish, which means we add and subtract accordingly to get all the x's or whatever letter on one side of the equation and all the plain numbers on the other side. And then our final step, like we did here, is I just say solve, but usually it involves division, dividing away whatever's hanging on to our, like here, we had a 10 chilling with our x, so we had to divide away the 10. These are the 4 steps that we're using to solve these equations with parentheses. Okay, Grace is ready. I'll be right back again. Thank you for being patient. She's not. Oh, do you want to come in? Okay. Good girl. I wish I could send you a visual of this gigantic, shaggy red dog standing outside on the step by the slider, drips of water cascading off her face because she always looks like Niagara Falls after she's drinking. Outside, the sun is shining, but it's been raining all day, so it's all sparkly and beautiful. And she's standing there with great expectation in her face and her tail wagging, waiting for me to let her in, knowing that I will disrupt a math lesson to meet her needs because that's how much she means to me. Okay, these are our steps. Let's do them on a couple more problems and see if we can confuse ourselves. We're on the 3rd one now. $31.3. Solve. I'm going to double check it. That is a 4. Okay, this problem is no harder than any of the others we've been doing, but it does have bigger numbers, and it does this confusing thing where it puts plain number before x number. That's fine, it doesn't matter. It just looks a little weird to us because we're not used to it. And the only thing that's hard about this is we have to do multiplication times 15 and 16, which is not necessarily the easiest thing in the world, but I think we can tough it out, don't you? And I will show you how my brain does it. Okay, 15 times 4. I don't know that right off the top of my head, but 15 times 2 I do know. 15 times 2 is 30. So 15 times 4 is going to be 2 30s, so that is 60. And then if that's 4 times 15, then 5 times 15 means I add another 15 to this. So it's 75x. Okay? This one's a little trickier. So this one I'm just going to multiply in my head. 4 times 10, this represents 10, right? 4 times 10 is 40. 4 times 6 is 24. So 40 plus 24 is 64. And then I'm going to do the same thing. I know it's a minus. I'm going to do this. I'm going to do 6 times 6 is 36. 6 times 10 is 60. So 60 plus 36 in my head is 96. And then this plus 10 is just chilling out on the end, so I tack him on. How you do the mental math that I just did here is up to you. There are lots of ways to see it, you guys. I'm not saying my way is the best way. I'm just letting you know how I think. What is important is that you do have some way of mentally combining these numbers. Oh, excuse me. You need to have some way of doing this so you don't have to scratch out the actual multiplication every time. You can do that. You can write it out every time and do the multiplication. The problem is that it slows you down. And that gets really frustrating when you're doing a big long problem and you have to keep stopping to do multiplications like these on paper instead of in your head. And then the other thing is that that's one problem, but when you're doing 15 problems in a row, it makes it so much faster if you can carry some of that math in your head. It just works much better. So I encourage you to find ways to do math in your head that makes sense to you. When I show you my ways, it's not me saying do it just like me. It's me saying, look, here's one way to think about it. Okay, we distributed. Now we're ready to add like terms. This and this are the only like terms I see. Remember, adding like terms is looking just at one side of the equation at a time and looking for any pieces that we can combine. It's not swimming fish. Swimming fish is when we go across the equal sign and we're moving them to one side or the other. But see, 64 and 10 are on the same side. So that's no drama. So it's going to be 74 minus 96x. Okay, I want to add the 96, so I'll have a positive over here. Right? And then I'm going to subtract the 60 because I need to swim the plane numbers, fishies, in the other direction, right? I got the x's out, so then I need to get the plane numbers out. This will be 21x. I can do that in my head. In my mind, what I do is I rearrange them so the 96 is on top and the 75 is on the bottom. And then I can see, oh, 6 minus 5 is 1, 9 minus 7 is 2. I didn't have to borrow. That's why I mentally rearrange them to see, is this a borrowing situation or a non-borrowing? It's a non-borrowing, so I can just really quickly calculate the difference. If I would have had to borrow, then I have to play a different mind game with myself, and I'll talk about that another time when we have a borrowing situation. 74 minus 60, that's 14. Yay! So now, all I have to do is divide both sides by 21, because I'm trying to isolate my x. This I see 7 goes into both of these. I'm not one who preaches about memorizing your timetables. I think understanding how to multiply is far more important than memorizing a bunch of numbers in boxes. But as we go on and have more and more complicated problems, if you can just quickly see patterns like that, boy, it helps a lot. So keep encouraging yourself to get those multiplication facts drilled into your brain. It's happening as you work. It takes 10 years for our brains to move information into long-term memory. So don't beat yourself up if it's taking you a while to memorize multiplication facts. That means you're normal. 10 years is a long time. So just keep chopping away at them. Just keep encouraging yourself. I'm dividing this by 7 over 7. I don't necessarily have to show this. I don't expect my students to show this. They can just go straight to 2 over 3. But I like very much to show you so that you can see what I'm thinking. There's our final answer. Do you like it? I do. I think it's great. Okay. I don't think I have room. I'm deciding whether or not I can fit the problem on the bottom part of that page. I don't like to squish, I'll be honest. 31.4. There are 5 in all. I told you that. Okay, ready? This is another kind of longish one. This problem illustrates a really helpful point. I'll give you a minute to finish copying and I'll double check it. Oh, this should have a plus sign right here. Okay, so we look at this and we go, okay, parentheses we have to distribute, but when we go and look, we go, dude, there's no number there. What are we supposed to distribute if there's no number in front? Well, we can always put a 1 here, right? We can always pop in what I like to call an angel 1. It's there whether you see it or not, right? And you can always make it materialize, which I suppose you can't. You can't always make an angel materialize, but I like to think they're with us whether we see them or not. What we are going to distribute in this case is not, the 1 isn't the important part, it's the minus sign. Okay, so when you have just a minus chilling in front of your parentheses, you have to distribute that minus sign across your parentheses. If it helps you to think of there being a 1 also, so that you're actually multiplying everything by -1, that's cool. If it makes sense to you, just say, oh, I'm just distributing the minus sign, then that's another way of thinking of it. In any case, we're gonna have 12 minus 2x minus 5. Okay? Cool. Now we go over here and we go, oh, here we have it again. I had to squeeze that plus sign in. Otherwise, we would think we needed to distribute that. But there's a plus sign. So again, we can squeeze in an angel 1 if that helps us. Or we can just think of it as distributing a plus sign. In either case, a plus sign doesn't change anything. So when we have a plus and then parentheses, we can just take the parentheses off. The signs will stay exactly the same, right? Because a +1 doesn't change anything. Over here we had a minus, that changed the signs. A plus does not change the signs. So that's a good rule to remember. All right, we're going to add like terms now, and I see that, and I see these guys. So this will be 12 minus 5 is 7 minus 2x, and this will be minus 5 plus x. Notice I'm not worried about the order here. We're going to be swimming everything in a hot minute anyway, so no worries. All right, I would like to make the x fish go this way. I want to add 2x to both of them. And if I'm moving the x's this way, that means I have to swim the plain number fish the other way, right? So that they'll end up on opposite sides. That cancels, and I get 12 equals 3x. So I divide by 3 in order to isolate my x. And we get x equals 4. We always reduce whenever we can. All right? I know, you're like, of course we reduce. Why would I not? Okay, one more, and it's the craziest of all. Of course, John always saves the best for last. 31.5. Here we go. Wow. That fit just exactly across my paper. Let me just double check. Make sure I got it right. You can finish writing. All right, those are a lot of parentheses. Those are a lot of friends screaming, do me first, pay attention to me, I'm needy. So let's just go in order from left to right. Here's minus in front of parentheses. Okay, we just had this. We learned that you have to distribute the minus sign across the parentheses to both terms. And we learned that if it helps you, you can put a 1 in there and think of it as a -1 being distributed, right? We just squeeze in our angel 1. Minus 4y plus 17, right? Minus gives you a plus. Okay, and then these are parentheses, and we see, okay, what's happening here? It's completely unnecessary to have the parentheses. We can just write it like that. Right? This plus doesn't change that. Pluses are innocuous. Okay, same thing here. There's no minus sign, there's no number in front, so we can assume it's a positive 1, right? If we want to think of it that way, we can think of it that there's a -1 that we need to distribute across, and we know that doesn't change anything. So basically, when there's nothing in front of the parentheses, you can just rip them off and throw them in the garbage. Down here, we're going to have to change that to a plus y. Okay, if you want to think of it as distributing, you can think of it as 2 minuses equaling a plus, or you can think of it as distributing that minus sign. Either way, it turns the y positive. Okay, add like terms. I see a y and a y, and then I see another y and another y. Remember, when we add like terms, we watch that equal sign and we only combine things on the same side. Okay, this is going to be minus 5y plus 17 equals 3y minus 1. Fishy swimming time. Just for fun, let's bring the y fish this way. Let's make them all super negative. They're complaining, right? Because they're very negative right now. Those cancel. Our y fish are over here, so we're going to swim our plane numbers this way. What do we get? Minus 8y equals minus 18. Okay. Divide away the minus 8 to get the y by itself. And we see, okay, this is going to go positive, but we can divide top and bottom by 2, right? And so we get y equals positive 9 over 4, because we divide both of those. Yay, that's the right answer. Okay. Once you feel like you're in the groove with these 4 steps, which are not a news flash, we've been doing steps similar to these all along, right? Once you get the groove of this, most students find these problems really fun and quite satisfying, all right? That is the end of lesson 31. I hope you enjoyed it as much as I did, including Gracie. She enjoyed it too because she got to go out and come back in. Okay, thank you. Goodbye.